Question 5. The curve C has equation y is equal to 5x to the power 4 minus 24x cubed plus 42x squared minus 32x plus 11 for x in the real numbers. Part A, find I dy by dx and II d2y by dx squared. So, with our starting equation, y is equal to 5x to the power 4 minus 24x cubed plus 42x squared minus 32x plus 11. Let's start by differentiating these. So differentiating, remember we multiply by the power and then reduce the power by 1. So this will become 20x cubed, 3 times 24, so minus 72x squared, 2 times 42 is 84x minus 32, and then 11 being a constant will differentiate to 0. So we've found dy by dx. Let's move straight on from here to do the same again to find d2y by dx squared. So multiplying by 3 and then subtracting 1 from the power gives us 60x squared. Minus 72 times 2 is minus 144x plus 84, and then now minus 32 is my constant, which will differentiate to 0. Part B, I, verify that C has a stationary point at x is equal to 1. So when x is equal to 1, we expect the gradient of our function to be equal to 0 when it is a stationary point, and we find our gradient by looking at our dy by dx, which is our gradient function. So substituting 1 into our gradient function, we get that dy by dx is equal to 20 minus 72 plus 84 minus 32, which does indeed equal 0. And so we can say that C has a stationary point at the value when x is equal to 1. Part II, we want to show that this stationary point is a point of inflection, giving reasons for our answer. And so the first thing we would expect, if it's a point of inflection, we would like the second derivative to be equal to 0 at the point when x is 1. So substituting x is 1 into our 2y by dx squared gives us 60 minus 144 plus 84, which does indeed equal 0. However, this by itself is not enough to say that it's in point of inflection. We need to consider whether the concavity of the curve changes before and after this value. So looking back at our second derivative, if we take a value below 1, so let's let x equal 0.9, then our d2y by dx squared value at 0.9 is equal to the following, which gives us a value of 3, which is positive. This shows that the curve is concave up before the value of 1. What we need now is for it to be concave down after. So if we substitute x is 1.1 into our second derivative, we get 60 lots of 1.1 squared minus 144 times 1.1 plus 84, which does indeed give us a negative value, which shows the curve to be concave down after our point, which means that given the 0 value for the second derivative and the concavity change, this means that C is indeed a point of inflection when x is equal to 1.